So hello students, yesterday we have discussed the problems on last sample test for single proportion. Now today we will see the problems on last sample test for difference of proportions. That means when we are considering two different samples of size n1 and n2, where n1 is greater than 30 and n2 is also greater than 30 here, right? Then to test the difference between the two population proportions, we know that the null hypothesis is capital P1 equal to capital P2. Okay. Now, again is the alternative hypothesis, it depends on the given problem. Now let us see the problem on this. A machine produced 20 defective articles in a batch of 400. After overhauling the machine, it produced 10 defectives in a batch of 300. Has the machine been improved after overhauling? Right? So overhauling means here the maintenance of the machine. Right? So here first we have to define the capital P1 and capital P2 here. So P1 represents the proportion of defective articles before overhauling the machine. Okay, then capital P2 represents the proportion of defective articles after overhauling the machine. Okay, then here our null hypothesis, it is always an unbiased statement. So capital P1 equal to capital P2. That means there is no significant difference in the proportion of defective articles before and after overhauling the machine. Then again as to H1. So for this H1 we have to once again read the question. So the question is here, has the machine been improved after overhauling? So improved is that. So improved we can consider it as a comparable word here. So before overhauling and after overhauling, definitely there will be some improvement in the maintenance of the machine here. So here H1 will be P1 greater than P2 because P1 represents a proportion of defective articles before overhauling. When the machine is being overhauled, then definitely here the proportion of defective articles will decrease. So that's why it is P1 greater than P2. Then under H0, the test statistic is given by small p1 minus small p2, the sample proportions, by square root of capital P cube into 1 by n1 plus 1 by n2, follows a normal distribution with mean 0 and variance 1. We know that the capital P formula is here n1 p1 plus n2 p2 by n1 plus n2. That is a formula for capital P. Now if you write the given data here, n1 is nothing but for the first sample it is 400 and second sample is here 300, right? So out of 400 here 20 are defective articles. That means small p1 equal to 20 by 400. So 20 by 400 is equal to here 0.05. Now similarly small p2 in a batch of 300, 10 defective articles are there. That means small p2 is 10 by 300 here. So that is equal to 0.03. Okay. Now using this we have to find the capital P value. So capital P equal to n1 p1 plus n2 p2. So n1 p1 means here n1 is 400 into p1 means 20 by 400. So that 400 into 20 by 400, 400 will get cancelled. So you will be having 20. So 20 plus similarly n2 p2. n2 means here 300, p2 means 10 by 300. So 300 will get cancelled. You will be having 10. So 10 by n1 plus n2, 400 plus 300 is 700 here. So from this capital P is nothing but 30 by 700. So it is here 0.04. Now we know that capital Q is 1 minus P, that is 1 minus 0.04 is here 0.96. Okay, now substitute in the Z formula. So small b1 minus small b2 means 0.05 minus 0.03 by square root of, here capital P into capital Q means 0.04 into 0.96 into 1 by n1 is 400 plus 1 by n2 is here 300. Now first let us simplify the denominator here. So 1 by 400 plus 1 by 300 is equal to 0.0058 into here 0.04 into 0.96. It is equal to 0.0002. Now square root of that is equal to 0.0141. Okay, now coming to the numerator here, 0.05 minus 0.03 is 0.02. So the calculated value will be here 1.4184. So Z calculated value is 1.4184 here. Now we have to obtain the tabulated value of Z at 5% level of significance, because nothing is mentioned regarding the level of significance. So by default we have to consider it as 5%. So at 5% level of significance for the corresponding alternative. So here alternative hypothesis is right tail, that means one tail here. So for one tail is here 1.645. So Z tab is 1.645 and Z calculated value is 1.4184. That means Z tab is less than Z tab. So H naught is accepted. H naught is accepted means here there is no significant difference in the proportion of defective articles before and after overhauling the machine. That means here P1 equal to P2. Right? If the calculated value is greater than tabulated value, then we can accept with this claim here. But here calculated value is less than the tabulated value, so there is no significant difference in the proportion of defective articles before and after overhauling the machine. That is P1 equal to P2. Now let us see the second problem on this. In a city capital A, 20% of random sample of 900 schoolboys has a certain slight physical defect. In another city capital B, 18.5% of samples of 1600 schoolboys has the same defect. So is the difference between the proportions is significant at 0.01 level of significance. LOS means here level of significance. Now if we clearly observe this question, we have not used any mean or average and variance or standard deviation here. And moreover, the data is not measured in any of the physical units, right? So here a physical defect is given. So physical defect that we can observe only, that can't be measured here. So this is the problem regarding proportions. And we have two sample sizes and the question is very direct, that is the difference between the proportions significant. So this is the test for difference of proportions. Now if we move on to the question here, solution, right? So P1 represents the proportion of defective students from city A and P2 represents the proportion of defective students from city B here. Then obviously the null hypothesis will be P1 equal to P2, capital P1 equal to capital P2. Then again as to H1, so there are no comparable words in this question. The question is the difference between the proportions are significant? So no comparable words means H1 will be 2 times, that is not equal to, P1 not equal to P2. Then under H0, the test statistic is Z equal to small p1 minus small p2 by square root of capital PQ into 1 by n1 plus 1 by n2 follows a normal distribution with mean 0 and variance 1. Now we know that the capital P formula is here n1 into small p1 plus n2 into small p2 by n1 plus n2 here. Okay? Now if you see the given data, n1 means the first sample size is here 900. Okay? Then the second sample size is here 1600. And the small p1 it is given as 20%. So here directly they have given the sample proportion. Now no need to calculate the proportion here. So it is 20%. 20% is here 0.2, right? And the second sample proportion is given as here 18.5%, which is equal to 0.185 here. Okay, now we have to compute the value of capital P using this formula N1 P1 plus N2 P2 by N1 plus N2. So capital P equal to N1 P1 means here 900 into 20% means into 0.2 plus 1600 into 0.185 is here 476. So 476 by N1 plus N2 means 900 plus 1600 is 2500. So it is 0.1904. Okay, then from this capital Q is 1 minus P, that is 1 minus 0.1904 is here 0.8096. Now substitute in the Z formula, small p1 minus small p2, that means 0.2 minus 0.185 by square root of here 0.1904 into 0.8096 into 1 by 900 plus 1 by 1600. Okay, now first simplify the denominator here. So 1 by 900 plus 1 by 1600 is here 0.0017. So multiply with 0.1904 into 0.8096. So it is 0.0003. Now square root of this is 0.0173. So this is the denominator. Now coming to the numerator here, 0.2 minus 0.185 is 0.015. So that means here, finally the calculated value is equal to 0.8671. So that means here, Z calculated value is equal to 0.8671. Now the calculated value of Z at 1%. So use 0.01 LOS means Z tabulated at 1% level of significance for the alternative hypothesis is here not equal to means 2 times. So for 2 times it is 2.58. Okay, so that means here Z cal is 0.8671 and Z tab is 2.58. So Z calculated value is less than the Z tabulated value. So H0 is accepted. H0 is accepted means here there is no significant difference between the proportion of physical defect among the two cities, right? So that means capital P1 is equal to capital P2. H0 is accepted here. Now let us see the last problem in this difference of proportions. Among the items produced by a factory, out of 515 were defective. Another sample out of 400, only 20 were defective. Test the significance between the difference of two proportions at 5% level. So here they have considered the defective articles here. So capital P1 represents the defective articles from the first sample and capital P2 represents the defective articles from the second sample. Then here our null hypothesis will be capital P1 equal to capital P2. Then against H1 the alternative hypothesis, here we have no comparable words, so simply they ask you to test the significant difference between the proportions. So no comparable words means here H1 will be P1 not equal to P2. Then under the null hypothesis, the test statistic is given by Z equal to small p1 minus small p2 by square root of capital PQ into 1 by n1 plus 1 by n2, where n1 and n2 are the two sample sizes here. Okay. Now we know that the capital P is N1 into small p1 plus N2 into small p2 by N1 plus N2 here. So if you see the given data, the first sample size is here 500, okay, and the second sample size is here 400. Now regarding the sample proportion, small p1 is here out of 500, 15 are defective, so 15 by 500, the sample proportion. So 15 by 500 is 0.03, and second sample proportion, out of 400, 20 were defective, so 20 by 400. So 20 by 400 is here 0.05. Now calculate the capital P value here. N1 into P1, that means 500 into 15 by 500. 500 will get cancelled, so we will be having 15 plus N2 P2 means here 400 into 20 by 400. 400 and 400 will get cancelled, so we will be having 20 by N1 plus N2. 500 plus 400 is here 900. So that means capital P is here 35 by 900 is 0.03. So capital Q will be 1 minus capital P, that is 1 minus 0.03 is here 0.97. Now substitute in the Z formula here. So small p1 minus small p2, that is 0.03 minus 0.05 by square root of capital P into capital Q means here 0.03 into 0.97 into 1 by N1 means here 500 plus 1 by N2 means 1 by 400. Okay, now first we simplify the denominator here. So Z equal to 1 by 500 plus 1 by 400 is equal to 0.0045 into 0.03 into 0.97 is 0.0001. Now square root of this is here 0.01. Okay, so the denominator is 0.01 here. Now coming to the numerator, 0.03 minus 0.05 is here minus 0.02. So the numerator is here negative. So definitely your calculated value will also negative here. So 0.02 divided by 0.01 is here 2. Okay. So Z calculated value is minus 2. So whenever the Z calculated value is minus 2, we can consider the modulus of that. So modulus of this will become positive, that is plus 2 here. So Z tabulated value at level of significance is given as 5%. So at 5% level of significance, for the corresponding alternative hypothesis is here 210. So for 210 means the value is here 1.96. So Z tan is equal to 1.96 and mod Z calculated is 2. So the conclusion is here mod Z calculated is greater than Z tabulated. So therefore H0 is rejected. So H0 is rejected means here we are accepting H1. That means here P1 not equal to P2. So capital P1 is not equal to capital P2. That means here there is a significant difference of the proportion of articles from the two samples, right? So that is the here test for difference of proportions. So with this we have completed the last sample test for difference of proportions. In the next class we will discuss about the small sample.